Thank you so much, Mr. Hamish. Thank you. And wish you all the best with your hard work. And I just want to say we appreciate you. And I have achieved like 93%. Sanbonani. This is Emma Onokula Wamkizis Bongo. I live in Devon in KwaZulu-Natal, and I was born in KwaHlabisa in KwaZulu-Natal.
Hey, how you doing, man? I'm Hamish. If you face time in this program, make sure you go to my website, and we collect all the donation. You appreciate everybody who did donation in the past. You might donate $1, $2, things that is small, but that's a lot for us, and we do appreciate that so much, because for me to sustain this project means I need your support. Okay, I can't do this by my own. That's why I decided this project, because it's for the community to support you, to support me, and we keep on moving. We can do as African continent. Okay, that's what I do. So you can, when you see me, you say, "Oh, that's African brother right there. He's doing. I can do the same too." Okay, so I just want to, empower, catalyze the people of the African continent. Now let's go. So now let's say question number 2. Okay, this is physical science, November 2019. Okay, now let's say here question number 2. They say black. You see this on the black. Let me just make thin a little bit. Okay, you know what I'm saying? So the black of P means, you see the black P here, black P. This one right here, make thin a little bit because it's gonna be too wide. Okay, size. Yeah, this is better. Okay, so now they say here a black P in a question. Block P means this is block P. So what happened, black P of mass 2 kilogram? Oh, which is 2 kilogram? Okay, 2 kilogram, and then it's connected with a block Q. Oh, which block Q? It's a block Q. But guys, remember, before I start to get this question right, let me explain to you something very, very important. Okay, so now let me just do this quick, just a second. Okay, let me explain something very, very important. Okay, if you have a triangle, and if your triangle is a right angle triangle, let's say this is my triangle, right angle triangle. Oh no, this is not a good triangle. Okay, let's draw a very good triangle like this. Let's see. Sorry, man, I'm not good at drawing. Don't laugh at me and say, "Oh, this triangle is bad, man. What is it doing?" Okay, so this side here, we call it hypotenuse. So you have to look at you see, right angle triangle, and then this is the angle here. Let's say theta. See, it's like this, theta. You know what I'm saying? Okay, and then the bottom one we call adjacent. So this is adjacent. So this is adjacent, and this side here is opposite, because we're gonna do a lot of this, and this is hypotenuse. Okay, so we know all of them. This side here is hypotenuse, and this side here is opposite, and this is adjacent. So now, how are you gonna remember the easy way? Look, whenever there's an angle is always between hypotenuse and adjacent. So if I have a triangle like this, right, don't worry about it, I'm gonna erase, right? I mean, if this is my angle, let's say it's angle alpha. Oh, so this is angle. So angle is always between adjacent and hypotenuse, and this is called what? Opposite. So you understand that, right? So now this is very, very important. Okay, let's say this is my triangle here, and somebody give me, let's say this is 4 kilogram. They say, okay, what is the opposite? Because this is opposite. Let's say this is y, this is x, because x is horizontal, which is adjacent. So just remember, right? Whenever you look for the opposite, this is opposite. Opposite always sine. That's the easy way to remember. My opposite is sine. Okay, so now you know how to identify opposite sine. So I'm gonna say sine. Where's my angle? My angle is theta. So sine of theta, and they always multiply by the hypotenuse before. See? So that's how you're gonna get this length here. Now, what about the adjacent? Adjacent always cos. So I'm gonna write here, okay? Our opposite is sine and sine, and then adjacent is cos. See? So that one we know. So now, how am I gonna get adjacent? Oh, adjacent is cos. So I'm gonna say, oh, that's a cos of my angle. My angle is alpha, theta, and then always multiply by this what? Hypotenuse, which is 4 for this case. So now you know how you can get opposite and adjacent. Okay, let me clean again. Okay, for example, So if somebody give me, no, let me just search something here quick, because there's something we have to play around with that. Okay, so if somebody give me, let's say this is 30, excuse me, it's 30. Let me draw a bigger triangle. Okay, let's say this is a bigger triangle like this, let's say. And this is 30. And now, this is, let's say 2 kilograms. So, now, which one is hypotenuse? Oh, we know for facts. This one is hypotenuse right here. So this is hypotenuse. And you know this is opposite. And this is what is adjacent. So how are we going to get opposite? Opposite is sine. So we're going to say the sine of angle. What is the angle? Angle equal to 30. So we're going to say 30. And then we multiply by hypotenuse. What is hypotenuse? Is 2 kilograms. So we're going to say 2 sine of 30. So we're going to say 2 sine of 30 equal to half. So 2 times a half, which is going to be by 2, 1 by 2, 1 equal to 1. Oh, so my opposite equal to 1 what? 1 kilogram. Okay, now let's get adjacent. Adjacent is cos always. Adjacent is cos. Okay, so adjacent is cos. So I'm going to say cos. What is my angle? My angle is 30, and then we multiply by hypotenuse. My hypotenuse is 2 kilograms. So 2 kilograms, and this is going to give us 2. Cos of 30 equal to square root of 3 over 2. Square root of 3 over 2 by 2, 1 by 2, 1. You can put in the calculator. It's going to give us square root of 3. That's the final answer. So now we know that trick, right? Now let's go to the business now. Excuse me, sorry guys. Okay, so not all the time they're gonna give like that. Just one more thing, guys, because I want to break down for you so that when you start to do the question, you know what is happening. So let's assume they give a triangle like this. Okay, say they give a triangle like this. Let's say there's a triangle here, and this is your angle. So now we know this is gonna be 90 degrees. So which one is so we know whenever there's an angle is always between hypotenuse and adjacent. So you see they kind of turn the triangle. So it's easy, man. So what I'm gonna do, okay? So you see how they turn this hypotenuse. Let's say hypotenuse equal to, let's say FG. I'm just saying equal to FG. Let's call it FG. So adjacent we know is cos. So I'm gonna say cos. What is my angle? My angle is theta. Theta, yeah. So it's gonna be cos of theta. But I will always multiply by the hypotenuse. So hypotenuse is FG. Oh, easy, man. And then, okay, now, so this is opposite here. You know what I'm saying? Because angle is always between hypotenuse and adjacent. So this is opposite. Okay, so our opposite, or you can call y, equal. How are we going to get opposite? Opposite, you know, is sine. So when I say sine, what is our angle? Our angle is theta. So when I say sine of theta, and then multiply by hypotenuse. What is hypotenuse? Is FG. So doesn't matter how they turn your triangle. What you need to do, look, okay, my angle always between is always between what? Hypotenuse and adjacent. Now let's go to our actual business now, to the question that means they give to me. Excuse me, sorry. So this is a question here. They say just like everything they say is what we see here. They say block P of mass 2 kilogram, mean there's a block P of 2 mass kilogram is connected to a block Q. So it's connected to a block Q. There's a block Q with 3 kilogram of mass 3 kilogram. Yes, by light inextensible strange. See, light inaccessible what? Strange means this strange here is like massless in other way. You know what I'm saying? So it's like what? Massless. So because you don't want to involve in any calculation, so we call it massless. And then they say block P is pulled by constant force of 4 Newton. Oh, so we pull this you see, by force of 4 Newton. So you see, they kind of pull it. Okay, let's go. Excuse me, let me move so I can explain to you well. So you see, it kind of be pulled here by 4 Newton. So they didn't pull it like horizontal like this. They kind of pull it like up a little bit. See, but even though I'm gonna pull it like that, it's still gonna be moving this way on top of inclination plane. Okay, now let's show something. Let me show you something here. Okay, 4 Newton. So now you see how they do here. So now I'm gonna have to find the component. What is the component? Look, look. This is a triangle. It's like this is 25. Excuse me, 25. And now I'm pulling with this force, which is what is 40 Newton. So I can get the component here. Because you know what I'm gonna get? This is 25. Okay. So now I know this is hypotenuse, which is 40 Newton. This is my opposite. Opposite. What is opposite? Is sine. Oh, so I'm gonna say sine of my angle. Angle is 25 degrees. Okay, 25 degree. So make sure you write all this stuff. Okay, 25 degree, and then you multiply by the hypotenuse. Hypotenuse is what is 40 Newton, because this 40 Newton. So say multiply by 40. Oh, so I'm gonna say a 40 sine of 25 is what's gonna give us what? This one here. You know what I'm saying? Let me use the other color. Wait just a minute. So that's gonna give us what? This one, which is what is 40 sine of 25. Sine of 25. Okay, sine of 25. And this is like adjacent, because this is hypotenuse and this is adjacent. So this adjacent is going to be what? It's going to be hypotenuse. We say sine of 25. Oh, sorry, guys. Sine of 25. And then you multiply by the hypotenuse, which equal to 40. Oh, so now we have a component of these 40 Newton, which are what are this vertical one, which is this, which is 40 sine of 25, and then the horizontal one is what is 40 cos. Oh my god, I apologize, guys. This is 40. Okay, this adjacent here, adjacent is cos. I made a mistake. You didn't even tell me. Come on, guys. I'm upset with you. So upset with you. So horizontal one here is going to be horizontal is cos of what? 25 means our angle 25 multiplied by hypotenuse, which equal to 40. So this is going to give us the horizontal component of this vector, and the vertical component is what is 40 sine of 25. So that one is clear. So we know all both components of this force. Now let's go to our business. So let me erase all this stuff, because now you understand what is happening. You know what I'm saying? Now, so that's where we at. Now, okay, let me just do this. Okay, cool. So they say first and foremost, the average. Okay, they say here I didn't finish reading. A block of mass P is moved to the rough. Oh, so AB is a rough. Oh, so here is a rough. Means if it's rough, we have what? Kinetic friction. See what I'm saying? We have what? Kinetic friction. Okay, because there's two types of friction. There's a static friction. Static friction is like, let's say you got box here on the floor. Even if this box is not moving, there is a friction. That's why you can put a shoes here for 20 years. When you come back, that shoes might be finished a little bit, or it might be like it was used a little bit. Or even, let's say, if you put a desk or anything for a long time, even a car, the tire can get broken. Like some car, like you come back after years, you find maybe the car kinda, they wear out and they kind of finish a little, because there is a friction despite the car is standing. So there's a static friction. Friction is static. Also, if something's moving now, there is a friction, but that's going to be what? Dynamic friction. Kinetic friction, dynamic friction. Okay, so that's how you know friction. Now let's go to our business. So now here we have a friction force, means you have a kinetic friction, but this one is smooth. Look, a block P moving in the rough section AB. So AB is the rough section of the inclination. Inclination, what that means maybe this guy was pulling this stuff, but from here there's inclination, means there's like a mountain or hill. You know what I'm saying? Now, what do they want? The average constant friction force of 22.5 Newton. Mean this is the friction force, the constant friction force on a block P as it moves from A to B. Oh, as it moves from A to B. Oh yes, A to B. Now, so only A to B is when you have, when you have that friction force. Now, let me just stop there. No, before we do that, excuse me. The first part here, they say state what? Newton's second law of motion, in words. So, I don't want to be all over the place. Let me just continue what I'm doing there, and then I'll explain you how you can draw force diagram first before we go further. Okay. So what I'm going to do, if I was in your position, I was going to draw something called force diagram. Okay, what we call it? Force diagram. So how you draw that force diagram? Let me show you something. Let me save this quick, and then I'll open your page. Okay, so I'm going to say come here, and then let's set this as our question. Okay, so we save as our question. I want to open a new page so I can explain to you how the force diagram, free body diagram, so you can understand clearly. Then when you come back, it's going to take only 1 minute, quick, and then we get done with it. Okay, so let me open the new one. Okay, let me just open something. Oh no, I got something new there. I don't know. Okay, cool. No problem. So now, for example, let's say we have inclination here. Excuse me. Okay, let's say you got, maybe you ride a bicycle, car, whatever. Okay, now you come. Oh, sorry. Okay, let's say this is a hill, like certain hill. Maybe you were coming and then you start from here. This is a point on the ground. So now when you come, let's say you start to ride a car. Let's say car. Okay, this is the first car, let's say, and there's another car. Maybe this car connected. Okay, you know I'm a big man, so let me say mine is truck, big truck. Okay, so now these two things. Just gonna do this. Meaning, look. So I'm gonna say it's easy. So what I'm gonna do first, you need to look at the direction of an object. Where does it moving or where is it going? So we know these two objects, because they're tied to each other, means they're gonna be accelerated to the top. Now, this is what we're gonna do, right? So if I know it's gonna accelerate to the top, what is that causing this car here? Because this is the one which is pulling the other one. What is that causing this car to go to the top of the mountain? Or is the force of engine for this case, or driving force? You can call force of engine or driving what force? It depends. Or force or driving force, or you say force driving or driving force. You know what I'm saying? So now that's what causing going up. Okay. Now if this moving up is going up there, now we're gonna say, okay, which force? Because we know for fact is gonna be force which acting what vertically down from a center of that car. So this is gonna call what? Okay, let's call this mass 1 of a car, and then let's call this what? Mass 2 of a car. So this force is gonna be acting down, and we're gonna call what? Let's say Fg. But since there's a two masses, mass 1 and mass 2, let's call this what? F1g, means force of gravity of face car. Okay? And for the second car, it's gonna be the same game, guys. So we're gonna say, okay, for the second car, we're gonna have the same game. Mean this is gonna be what? Force of gravity, but this is the mass 2. So let's call what? Force of the second car, G. Cool. So now let's see resolve. So now this is a force diagram I'm showing you, right? The ratio of the stuff is gonna come. Now we know we have something called normal vector. Normal vector, normal force is the force which comes from the surface toward the car, but it must make angle 90. For example, if you have a horizontal surface like this, okay, horizontal surface. So now we know if this car on object, let's say box or whatever, it exert a force toward the floor or on the table or whatever you have, this force we're gonna call force of gravity, because vertical downward. And also this table, see this table here, is gonna exert the same force opposite, which you're gonna call what? Force of normal. So force of normal comes from the surface toward the object. Excuse me, but the force of gravity starts from the center of this object under. And you see, normal force always make angle 90. Normal force angle or it make angle 90 with object from the surface toward the object. Excuse me, guys. Okay, now let's go. So normal force always comes from the surface toward whatever you have, whatever object, but it always make angle 90. Means 90 degree perpendicular. Normal force perpendicular to from the surface to an object. Now let's come back to this case now. So you gotta be very careful here, guys. I want to explain something very, very important concept. So now, where's the normal force? We know force of gravity is always vertically down, guys, vertical down. But a normal force, it comes from this surface here toward the object. It must angle 90. See, it make angle 90. Can you see that? So same here, our normal force. So this is gonna be force normal. This must 1, right? This must 1. So this was normal 1, F1 normal, and this is gonna be what? F2 normal. So now what you have to do, let me use another color here because this is very, very important. We're gonna have to resolve the vector. Means extend it, look, you extend it. The normal face you extend, and then you do the same thing. The next thing is you need to connect and make the triangle. Okay, so let's assume from this inclination with the horizontal, it make angle theta. Okay, so this angle theta is always same with this, And this, the same angle theta, is same with this. It's the same thing. So let's connect this triangle now. See this triangle here? Let's connect. So how are we going to connect? When you connect, make sure, you see this one here is always parallel with this line here. Very careful, guys. You see parallel. Parallel is something which they never meet. Look, these are parallel. Look, these are parallel. Mean they never meet. So now, this line, it must be parallel with this. And you see this one, these are angles. So we know angle is always between what? Angle is always between what? Between hypotenuse and adjacent here, adjacent. And this hypotenuse. So for that case now, I don't have to write adjacent or whatever because I know them. Adjacent is cos. Oh, so this side here is going to be cos. Oh yeah. Okay, so this is going to be cos of my angle. Angle is theta, cos of theta. But we must multiply by the hypotenuse. What is hypotenuse? Hypotenuse is Fg. So F1G. Can you just say Fg or F1G because it's for mass 1. And this is the opposite. Opposite sign. So I'm going to say here it's going to be what? Right here. So it's going to be what? It's going to be right here is opposite. Opposite is sine. So I'm going to say sine of my angle, which is this, and then multiply by the hypotenuse, which is what is F1G. Oh, you see what I'm saying? And the direction of this is this way, and we call this decelerating force, guys. It's called decelerating force. This is decelerating what? Force. Now let's go for a second triangle now. For second triangle, we're going to do the same thing. Mean this and this must be parallel, and direction is down. And we call this decelerating force. So this is adjacent. Adjacent is cos. So I'm going to say cos of my angle multiplied by the hypotenuse. Hypotenuse is F2G. How did I know that, guys? Like I say, this is my angle. So angle between what? Hypotenuse and adjacent. Adjacent is cos multiplied by the hypotenuse of 1G. And for this one is opposite. Opposite is sine. So sine and then multiplied by the hypotenuse of 2G. So now let me explain something very, very important, guys, here. Okay, very, very, very important. Let me go use a black color. So you need to identify where this object is moving. This object is moving up. If this object is moving up, okay, now, so we're gonna split two things here. You know what I'm saying? Now we wanna do, we wanna solve. So how are we gonna solve? Let me open new page. Let me open new page, guys, because the space is not enough. So, let me start. So what you do, you can split it like this. Look how I'm gonna split. You don't have to write like that, but in your back, in your mind, like solve this separately. You see how I split it? Solve this and then solve this separately. Okay, so I'm gonna get rid of that. Okay, so now what you're gonna do, you're gonna say, if I start with this mass 1 from the Newton's second law of motion, we say F net, can do this, equal to ma. Space is not enough here, so what we can do, let's open new page. So if I start with this, see this object, what is the force going up? So you need to know the direction. So from Newton's second law, we say F net equal to ma. Mass times acceleration. So you have to look like where this, you need to know where this object is moving. The object means mass 1. Mass 1 is moving to the top. So the force which is moving to the top is what is force of driving or force of engine. So it means force of engine is bigger than any force which is opposing. Which force is opposing? It must be friction force here. And also we have this force here, decelerating force, also is moving down. And also tension, because this stuff is moving up means tension is going to be opposing. Tension is always on a string, on a rope. Oh, so now for that case, let me do this because this is getting dirty now. Okay, so let's get a new page. Okay, now what I'm gonna do, I'm gonna say okay, let me start for object 1. So say F net equal to mass. So this is mass 1. Okay, so which force causing moving up? you take the force which is where object is heading to, you minus all the other which is opposing. So for this one, we know driving force or force of engine. So we're going to say, okay, so F net meaning force of engine or driving force minus. Which force opposing? Oh, tension, no, friction force, because if this car moving this way, the friction force is going to be moving on opposite. Friction, kinetic. So this is dirty, guys. So we're going to say minus which force opposing. So you have a picture. So even if we go to the question, you understand. Meaning if this stuff is moving up, the force which is going to opposing here is what is? Friction force and also tension. So I'm going to add all of them. So okay, so which force opposing? Tension plus, you add all of them, friction force of this first one plus another one, force of decelerating, which is Fg sine of angle. All those are forces, and then you say equal to ma m1a. Okay, so it's too dirty, but you understand. Okay, now what about object 2? Like I said, don't do them together. So for object 2 means is this here. So now look, remember here there's a tension here. If this stuff is moving up, mean tension is always opposed. Okay? Let me use another color because this is getting dirty. Okay, so tension always cancel on another, means here also there's a tension. And if this stuff is moving up, because moving up, what is that causing moving up? Don't worry about this anymore, right? Don't focus on this because we're done with this. So the force which is moving up is what is? Tension. And what that opposing? Friction force. And what then? Decelerating what? Force, which is F2 G sine theta. So you take tension to get F net, you take what? Tension minus all the force which you're opposing. What is opposing? Friction force plus decelerating force, which is Fg sine theta, and then we plus, no, nothing else. So equal to ma, means equal to this ma. So now let me go to the business, because you have it roughly what is needed, and then you can see how I can break it. Okay, now let's come here and open our equation. This is our equation. Okay, just save this because I want to need it. Maybe drink some water. Sorry guys, I want to drink some water, man. It's tasty. Okay, cool, let's go guys. So now what we're gonna do now, I'm not gonna draw everything, we know. Okay, so let me start. They say okay, it said Newton's second law of motion. So now you understand what is happening in this question. Now they say state Newton second law of motion in what? Okay, from Newton's second law of motion in words, look, Newton says, for example, if you have an orange or your car, let's say your bicycle here, and then you leave your bicycle in your house, maybe at your yard or at your village. If you come back after 20 years, the bicycle must be there. Let's say you lean it on the wall, or you just put it like it's standing. It has to be standing. Exactly. If you come back after 10 years, if that bicycle has moved, it has fallen, how did it fall? How did it move? Because of the external force. What are those external forces? Maybe your brother came and ride the bicycle, or somebody push, or the wind kind of push. So those we call them external force. So an object will remain in its state of rest unless somebody had touched it or moved. So those stuff which is kind of disturbing, maybe move or wind or whatever, we call them what? External force. Also, Isaac Newton say, if you take a ball, let's say this is my ball, and then I throw it, the ball's supposed to go forever. Why does it go maybe on top? Let's say you throw the ball to the air. How does it go and then it fall? Because of the air resistance. See, because of the air resistance. Or if you kick the ball, why the ball maybe it goes and then it stops? Because there's a friction force on the floor, or air resistance. So those we call them what? External force. So external or resultant force. External force. So the ball we're supposed to move with a uniform motion, like forever, constant motion or constant speed. Why does it change? It changed because of somebody maybe stab your ball, or the wall, or the rack stab it. So those we call them what? External force. So according to the Isaac Newton, they say an object will remain at rest. This should remain at rest, or it's supposed to continue the same speed unless there is an external force at otherwise or upon it. Okay, so I think now you understand about Newton's first law. Okay, now draw free body diagram of block P. So free body diagram of block P. So draw all your force like how I did before. Okay, so I'm gonna say okay. So see this force of normal, and then we know this force of gravity. I think now you understand. I think I'm saying here, so gravity, and then we know this is tension here. Because if this stuff is first, you have to know where this object is going. Because if you want to do whatever you do without knowing the direction of object, there will be trouble. They say this stuff is going to be moving up like this, means it's going to accelerate to the top. Meaning we need to know which force horizontal, because we want to know the same direction. If this stuff is 40 Newton and this is the angle, oh, so horizontal is cos, so it's going to be okay. So it's what is 40 cos of 25, and this is what 40 sin of 45. But we don't need this 40 sin of 45. We don't need it. It's 40 sin of 45. Okay, now because we want to do something horizontal. So if something moving this way, what that's going to be opposing? Tension here is going to be opposing. Use it quick. It's going to have what? Tension which is opposing. And another thing, remember, it's going to be like this. Meaning, things you know there. Okay? So this one here is Fg sine theta, decelerating force. Fg sine of what of? This angle, it must be same with this one, 30. So Fg sine of 30, and this is Fg cos of 30, because this is adjacent, this is the angle, this is the hypotenuse. Adjacent is cos, opposite sine. So the force which is opposing 40 cos of 25 what are this tension, and there must be friction force which is opposing here. So now if you come for object 2 here, what is that causing? Because tension always faces one another. Tension is like facing, for the object one, tension is facing this way, so the other tension must be facing one another, because tension, they cancel one another. You know what I'm saying? So we're gonna say, I'm gonna raise everything because the tension is for block P. Excuse me, sorry, I apologize. Okay, cool. So for block P, so this is force of gravity. Sorry, my handwriting is not too clear. It's not nice. Let me draw vertical. It's like this. Yes. So if you had to prolong like this, look. This also going to be 30 here. This going to be 30. And now this is Fg sine, because if this is the angle, adjacent, opposite. Fg sine of 30, which is going to be moving down. Okay, what you call decelerating force. Now, so this force here is tension, remember. Like I say, tension, they cancel one another for this case, because it's moving up, tension chose, opposing, so this one must be facing one another. Okay, what is the other force? Here we're going to have a friction. Oh, I made a mistake. For the first one, there was no friction because it was smoothie. So for this one here, there's a friction, because they say from the question, oh, this is going to be rough. So we have a friction, what? Friction of kinetic. But no, here is only tension. There's no tension here because there's no rope. You get tension only when there's a rope. Now, so free body diagram, meaning you draw all those actual forces. Now, this is the free body diagram of mass 2. Let me show you now. Because what I just draw now, this is a force diagram. This is a force diagram of P. Now, free body diagram. So free body diagram, all you do, you draw only arrows. Means, you see this stuff here? You draw this arrow. Like, dot is where weight is, I mean the weight of this object. Okay, what is the first force? See? Kinetic friction. So you draw the same direction. Fk. Okay, now we have a normal force. Another force, tension, Another force is force of gravity. So do not draw these, because these are just component of this actual force. So you don't need this, the one extended. No, you just need the dry. How I'm gonna say the actual forces. So this is a free body diagram of mass what? Mass 2 kilograms. And then after that you must make sure you say in exam, like, okay, you just say this is normal force, this is kinetic friction, this is the force of gravity, and this tension. You must mention, you say Fn is force of normal, Fk kinetic friction. You know what I'm saying? Okay, so I hope I did answer. Now, it's not part of the question, but draw free body diagram of Q. Now, it's not part of the question, right? Like I say, I'm explaining so that you can understand. So in the future, you can be able to solve any question. Okay, free body diagram of Q now. Okay, so I'm going to say free body diagram here. Okay, so first we have so we know we're going to have a normal. So we have a normal, force of normal. Another force, tension. So tension. Another force, you see this force of gravity. So we're going to have force of gravity here. Another force, we know here we got actual force. You only take actual force, right? You don't take the component. You know what I'm saying? So these are all the force, which is 40 Newton. Force applied, you can say Fa. Force applied, you can just put it 40 Newton. You know what I'm saying? So we didn't have this. So don't write the component, even though you know we can get it, because it's just gonna be what? 25 what? Cos 40. See here? So it's gonna be what? 40 cos of 25. But you don't need that, because you don't need the component. You need the actual force. So this was gonna be the free body diagram of what? Of 3 kilograms. We're done. So now I believe you know how to draw free body diagram. Okay, so we did already for both, even though they didn't ask us. Now, calculate the magnitude of acceleration. Calculate the magnitude of acceleration of block P while moving P to a section of AB. Means the one what? Acceleration when this P move from A to B. Very good, I like this. So you cannot solve that if you don't know what I just showed you before. So this is what we're gonna do. How does the P move up? The P move up because of the tension. Because remember, you know what I'm saying, is tension. So you have to know the phase before you solve this question, guys. This is very important, man. Look the direction, because if you don't know the direction of an object, then you don't know how the arrow is gonna confuse you. So we know this stuff is gonna be moving up like this. Okay, now, so we know there's a friction force here, because they say it's a rough. So F friction, and then also we have what? Force of gravity. You know what I'm saying? And then we know we got this. It's a force of gravity, and then after we got this. So you take all the horizontal force. These are horizontal force like this. So let's say these are the one you need, like where the object is moving to. Those are horizontal force, like you see this direction. Those force you deal with. But you see this force here, you know what I'm saying? I mean these. That's the one you deal with them for the most, for you to get acceleration and tension. You know what I'm saying? I'm gonna raise this because I don't need this rubbish here. Okay, so now here we know. So this one here. So this one here is what is Fg. This one here is moving down. Decelerating force is Fg what? Because look, this is the angle, and if this is the angle, means this adjacent, which is Fg cos theta. So this is Fg sine theta, just like how I say sine of photo 30 for this case, because it's 30. Now, so now how are we gonna get the acceleration? It's easy, guys. So what I'm gonna do, I'll say, okay, so do not deal with this, leave it for now. So I'm gonna say where this object is going, up or down, is moving up, we know, because they explained that. So I'm gonna say now, how does it move up? What is that causing moving up? Is this tension here. So don't solve them together, you're not gonna win. You know what I'm saying? So I'm gonna say tension minus all the forces opposing. What is the force opposing? Kinetic friction and Fg sine theta. kinetic friction and G sine theta. Okay, cool. So in another force, yeah, that's all. So means this tension minus what? A G sine theta minus Fk, and then equal to ma. Okay. So now we want to say, okay, so F net equal to ma from this is Newton's second law. F net equal to ma. This mass times acceleration. So which mass now? 2 kilogram we know. So how we want to get F net? It's easy, man. So we say F net means force of net force. So take where object is moving, which is T, minus all the force which is opposing. What is the force opposing? Fk, which we have. What is that? They give us here in the question Fk somewhere. Magnetic acceleration while P moving to AB. Okay. Oh no, it's okay. It's okay. I somewhere think they give to us. Let me read. Oh, this one here is put by constant. No, it's not. It's not. Okay, see. Oh, let me check careful. Oh, this one here. Sorry, guys. I got it. I see I wrote roughly a little bit. My apology. This one here, see? 2.5 watt Newton. But I just mix a little bit. 2.5 watt Newton. Hold up. They say here constant friction force is given. Okay. So we're gonna say F, okay, and then we're gonna add what is another opposing? F G sine theta, because look, they move this way, they move this way. F G sine theta equal to ma. So these you need for now. But remember, they say this stuff was moving with the constant velocity or constant force. If anything, no, didn't mention them, guys. I apologize, man. I'm trying to make it up here wrong. Okay, so do you have a force of kinetic? Yes, we have Fk here. We have which equal to 2.5 is there. So I'm gonna say tension. We don't know. Minus F. F is 2.5 plus Fg. Fg meaning force of gravity. Fg equal to mass times gravity. Okay, mass times gravity. So Fg meaning what is your mass? Our mass is 2 times gravity is 9.8, which is going to be 19.6. Okay, 19.6. So this 19.6 and sine of 30 because sine of angle. So 19.6 times sine of 30. Sine of 30 is a half. So 19.6 times a half is gonna give us 9.8. So these together is gonna give us 9.8. But you must show means Fg means mg times sine of 30. So this is gonna give us 9.6 times sine of 30 means what? A half. So which is gonna give us 9.8. Okay, so we got it. So we're gonna say plus what? 9.8. And then equal to ma. Mass is 2 kilograms. You see this ma? Mass is equal to 2 kilograms. Sorry guys, times A. So 2A. So T plus 2.5 plus 9.8 equal to 2A. Okay? Now 2.5 plus 9.8. Can you do it aside? 2.5 plus 9.8. Okay, this will be 3 and 1, 11, 12. 12.3. Okay. So these two give us 12.3. 12.3. So T minus 12.3 equal to 2A. T minus 12.3 equal to 2A. So I don't need the rest of the stuff. I can just get rid of them. That's what I needed. So we say T minus what? 12.3 equal to 2A. So this 12.3. This is the first question. So we can write aside. And then we have to do the same procedure because now you see we kind of stuck. We don't know tension, we don't know acceleration. So I'm gonna leave this as a pending, and then I have to do the same thing for the second object. Remember guys, this is 80 marks, so they can't just give it like baby, give it. Now I'm gonna have to do the same tricky for this object, and then I'm gonna get a question which has a T and A, and I'll solve them simultaneously. So my question aside is what is T minus 12.3 equal to A. Okay, that one is a side. I'm going to write the side here. T minus 2.3 equal to 2A. Okay, so I'm gonna erase everything and then we'll come back for it later so we can have a space. Okay, now, so now we go for this object here. Look, like I said, I need a horizontal force. Horizontal force is this. So this is adjacent because look at your angle. So adjacent is cos. Oh, so this is like cos of what, of 30, and then times what, times 40, times 40. So 40 cos of 30. That's handwriting very dirty. Okay, so it's gonna be 40 cos of 25. It's not even 30 cos of 25. My apologies, I'm wrong. I was wrong. So I'll say, okay, this is adjacent. Adjacent is cos. So this side is what is cos of 25 times what, times hypotenuse, which equal to 40. So this is the component of this vector which make this moving out horizontal up. Now, what is opposing? This is opposing, which is what is tension. How did I know? Because it's moving up. So tension is opposing, and another thing opposing, friction force. No, we don't have a friction force for this case. It's supposed to be friction force, but the only rough place is this. So there's no friction force here. I mean, this surface here. Okay, cool. Now let's go. Let's keep on resolving. So we know if we had to draw the triangle, we know FG is going to be acting down. And also we have this. Okay, so this is going to be 30 as this. So this is 30. And this stuff here is going to be what? Moving down, decelerating force, which is what is FG sine of what, of 30. Okay, now, so we can see now which force is causing to move up in this. So we're going to say, okay, first net, let me use other color here. First net, from Newton's second law, we say F net equal to mass. Make sure you write on top from Newton's second law of motion there. Make sure you write there. Okay, where is it moving? You have to know it's accelerating. It's accelerating this way. And the force cause moving this one, which is 40 cos of 25. You take the horizontal one. Don't use this. You use the horizontal one. 40 cos of 25. Oh, so it's 40 cos of 25. Count 40. So 40 minus. What is the opposing? Oh, the opposing one? Oh, we know. That's right. Oh, tension, no tension. No tension, yes, tension. Because this tension. And another one, do I have a friction force? No, because this was smoothless surface. So the other force opposing FG sine of 30. So FG sine of 30, what is FG? Mass times gravity. Means this FG is mass times gravity. This mass times gravity. So what is the mass for this case? It's 3. So 3 times 9,80 and sine of 30. Sine of 30 equal to half. So times what, times a half. Let's do the side. So we say by 2, 1. By 2 is going to be 4.9. So 4.9 times 3. The side. I don't have a calculator today, so do manual. 4.9 times 3. This is going to be 7. And there go 2. It's going to be 12, 14. 14.7. Okay? So all this stuff is 14.7. Which you're going to say with plus here what? But you must write faces FG sine of 30 because my space is not enough. So FG sine of 30, which I know is 12. Which got me 14.7. Make sure you show all this stuff, guys. You know what I'm saying? So here you plus what? Make sure you put your bracket. Means this force is the one up minus all the one opposing. Plus what? Plus FG sine of 30. And then equal to ma. You know what I'm saying? And if G sine of 30, I just did calculate, it means mass equal to 3 times gravity 9.8 times sine of 30, and all them together is going to give us what? It's going to give 14.7. So here it must be 14.7. You know what I'm saying? And 40 times cos of 25. Oh my God! Now, I know where's my calculator, but I can figure out, no problem. And then excuse me, just a second. So I'm going to say 40 cos of 25 is going to give us 36.25. 36.25. Okay, so this is 36.25. Now let me plug in the number. and mass we know 3 times acceleration. Okay, so now it's gonna become, especially not enough, guys, so I'm trying to play clever here. So I don't need the rest of this stuff, I can just do my thing. Okay, cool. Now, so 40 cos of 25 equal to 36.25. 36.25. 36.25. That was 40 cos of 25 minus tension, I don't know, plus, because this you add all the force which is opposing. See this force, you put them together, I mean the one was opposing. Fg sine of 30, Fg sine of 30, it give us what? 14.7. So this 14.7 equal to mass equal to 3 times acceleration, we don't know. You know what I'm saying? So now I can put this one in, means it's going to be 36.25 minus t minus 14.7. Oh, so you're going to have 36.25 minus t minus 14.7. So this is going to be 36.25 minus 14.7. And when you minus it, it's going to give us 25.55. 25.55. So I'm trying to play clever. So that's going to give us what? 21.55. 21.55. So this is going to be 21.55 and then minus t equal to ma, mass equal to 3 what? 3 times a. Oh, so this is what we have for the second object, and for the first object also we had something, which is what? T minus 2.3 equal to 2a, which was what? T minus 2.3 equal to 2a. So you're going to have to solve these two simultaneously and get the value of a and t. So solve simultaneously, that's going to be another thing that's very, very basic. You can solve simultaneously and you can get the value of a and t. You know what I'm saying? I expect you know how to solve simultaneously, because this is like 12th grade or 11th grade. So solve those two simultaneously. It's going to give you a equal to what is a? A is going to give us a equal to 1.85, and our tension equal to 16 Newton. You know what I'm saying? So you can solve these two simultaneous, guys, by either substitution or elimination, which is very, very basic. You get acceleration equal to 1.85 and tension equal to 16 what? Newton. If you don't know how to solve simultaneous, you can go to my video. I explain everything about simultaneous. So now that's how you do the second part, which has a so you see acceleration is what? 1.85 and tension equal to 16. I mean this tension here is less compared to, because look, this force must be bigger than tension for this case if this object is moving up. And you see 440 times cos of 35, we get what? 36 point something, which is bigger than 16. That's why the object's moving what? Up. Now let's go to the last question here. Excuse my apologies, guys. If the block P has now passed point B, oh, so this block you see just moving a rough here, and then it just passed here. If it passes, we know there is no rough here, no rough surface, means it's going to be moving fast. In other words, it's going to accelerate what? More faster, because the net force is going to be big. The net force is going to be bigger. So now they say here, according to the equation, if the block P passes point B with the acceleration compared to the, how we're going to compare? Oh, to the one we got. Oh, this acceleration is going to be bigger because here is there's no friction, it's smoothless. So acceleration will be bigger or greater. They say greater than or less, more greater than. Why is greater than? Because it's smoothless surface. Or you can say net force is bigger, is greater than, compared to the net force here, because there's no friction force here. Means all this force minus no friction is going to be bigger compared to here. Means if you take this tension here, you must minus this, you must minus, it's going to be too much stuff that you minus. But here, no friction force, so means the net force is going to be very big. So the answer, acceleration is going to be greater than. Reason, smoothless surface, because it's smooth surface. First reason. Second reason, F net is bigger because there's no friction force, which is opposing. So F net is bigger than or greater than. So that's it, man. Here the reason we got it 2 marks. We got all the marks. Let's see how many marks. 2, 6, 2 plus 4 is 6, 6 plus 8 is 14, 18. Got it. Most things, it's just a waste of time. How you do this question? It is easy like that, man. Thanks a lot. You know what I'm saying? Look, man, I believe in learning from how I do things. If it's make sure you subscribe, and you know, you can just go and do donation to our Patreon page. I have a Patreon, I have a GoFundMe. You know what I'm saying? I have all the means of donation because to make this project going, you know, any type of donation, the little that you think is too small for you, it could make a lot of change. And thanks a lot for all your time, you know. Subscribe, don't forget, share this video, circulate to a lot of people, you know, because the meaning of this project, this program, is to help as many as we can. Okay, it's not only for one person or two, because you might think it's not helpful for you, but for somebody next out there, it could be very, very helpful. So thanks a lot, man. And you know, any donation that you did to me, it means so much. I appreciate it, man. It means a lot. Go to our Patreon page, go to our GoFundMe, because we need to have a lot of things. We need to put them together, like camera, you know, and a lot of equipment, so that we can improve on, you know, a lot of angle, a lot of aspects of these projects. You know, thanks a lot, man. I appreciate and I love you. Peace and out. Bye. You know, this is one of my students of knowledge. You know, she wanted to introduce herself. What's your name? Could you please introduce yourself?
My name is Kali. I
Yeah.
go to Southend Primary School.
Yeah, China Wabantu. China Wabantu is everywhere, right? So this is my other student. His name, what's your name? Matthew, yeah, he's grade 11, man. So his aim is to score distinction, right? So you promise, I want you to score distinction this time. And what's your name? Joshua, how much you promise me to score this time?
Distinction.
Distinction. Yeah, so China Wabantu is everywhere, man.
China Wabantu.
Uh-huh.
China Wabantu everywhere.
Everywhere.
China Wabantu.
Exactly. Thanks a lot, man. Appreciate it. Thanks so much. If you had to give advice, which advice would you give to the people or to the students?
Trust Amish.
Why would they trust me?
No, because it's really good. It actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Amish said lots of hard questions, and it's demotivating sometimes to do the harder stuff. You just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.